Properties of construction steels. Steels used in construction can vary in mechanical properties depending upon their alloy composition. Taking a bar made of S275 steel and looking at its stress-strain behavior when a load is applied, the material becomes stressed. The bar also elongates. It is subject to strain. A further increase in load sees the bar elongate more as well as become more stressed. The linear nature of the stress-strain plot indicates that the material is behaving elastically. If the load is removed at this point, the steel bar will go back to its original shape, like an elastic band. Another load increase sees the stress-strain plot begin to curve. It is said to be behaving elastic plastic, and is an indication that the steel bar is becoming permanently deformed. Where the plot begins to curve is called the limit of proportionality. At the end of this curved section is the yield point. Past a certain point on the stress-strain plot, there appears to be an elongation in the steel bar without any increase in load or stress. The steel material is behaving plastically, like a paperclip. At this point, if the load is removed, the steel bar has permanent deformation when compared to its original shape. Reapplying the load, the stress-strain plot picks up where it left off. From this point onwards, as the steel bar is elongating under load, an increase in stress is noticeable. Dislocations within the microstructure are tangling up and causing this increase in stress. At the end of this section, the ultimate tensile strength is reached, followed by necking of the steel material and then failure. This is a ductile steel, and examining the failure specimen, it looks like a cup on one side and a cone on the other. S355 steel shows similar behavior but has a slightly greater strength. For S460 high tensile strength steel, more carbon is alloyed with the iron, changing the behavior of the curve. The elastic modulus, or stiffness of the curve, begins the same, but the limit of proportionality and yield point are much higher. However, beyond the yield point, there is a much reduced ductile zone. This is brittle steel. Grade 304 stainless steel has a much lower limit of proportionality. The stress-strain curve departs from linearity at a much lower stress. However, the curve exhibits extremely ductile behavior, and although there is a large non-linear portion to the curve, the ultimate tensile stress reaches a similar value to S275 and S355 steels. After the ultimate tensile stress, there is still some further ductility to the curve. Considering the two most common types of construction steels used, there are some important values when we are checking to see whether a particular steel member is strong enough. Firstly, the ultimate tensile stress. This is the absolute maximum stress that the steel member can withstand. Unfortunately, if the member actually reaches this value, there is some permanent deformation when the loading is removed. The member may be damaged beyond reuse. The ultimate tensile stress for S460 steel is shown to be much higher. Another important value is the yield stress. Any removal of load at this point will result in the member going back to its original shape. It can be reused as many times as necessary. Again, the yield stress for S460 steel is much higher.